In March of 2025, a United States Space Force general stood up at a defense conference in Washington and announced that China had been dogfighting in space. His name was General Michael Guetlin. What he actually described was 5 Chinese objects in low Earth orbit, maneuvering in and out and around each other, in synchronization, under control. Then this July, the Space Force ran its first tactical orbital intercept, the Victus Haze mission, sending one commercial spacecraft to close on another. Orbital warfare is now formally a Space Force mission. Space Command and its allies are supposed to finish writing the operations plan for it by the end of this year. So it's happening. Good. But I want to go back to that word, dogfighting. Because a dogfight is a thing that happens between 2 fighter pilots at 300 miles an hour in about 90 seconds, and it is won by whoever has faster hands. Those 5 Chinese satellites were not doing that. They were doing something that unfolded over days. A few analysts pointed this out at the time, that dogfighting implies a tempo orbital mechanics simply does not permit. They were right, but I think they undersold it. It isn't just the wrong word, it's the wrong branch of the military. Here's the claim. Every space navy you have ever seen in fiction is a surface navy. Star Wars, Star Trek, Warhammer 40,000, Battlestar Galactica, same template every time. Ships in formation, a commander on a bridge with a window in it, fighters launching off carriers, broadsides at a range where you can actually see the other guy. That's the Battle of Midway. That's Trafalgar. That is the age of sail with a better lighting budget. And it isn't merely unrealistic. It's the wrong sport. Space is not an ocean surface. Space is much closer to the deep ocean. And we already have a branch of the military that spent 80 years learning to fight inside a 3-dimensional void where you cannot see, cannot phone home, and cannot be rescued. We call them submariners. Almost everything they know transfers. 5 reasons, then the one objection everybody raises, which I promise to deal with honestly. Reason 1. The captain is alone. In fiction, somebody is always giving orders in real time. The admiral says, "All ships break left," and all ships break left, and it looks fantastic. Physics says no. Light is fast. It is not instant. Earth and Mars at their closest are about 3 light minutes apart. At their furthest, closer to 22. Jupiter runs 35 to 50 minutes out. So picture an admiral at Earth commanding a fleet at Jupiter. He sees the enemy arrive. He issues an order. His order lands 40 minutes later. The report of what happened comes back 40 minutes after that. That is not command. That is correspondence chess. Except the pieces are people, and half of them are already dead by the time you move. Submarines solved this 60 years ago. A ballistic missile submarine on patrol is functionally unreachable. To receive a message, she has to come shallow, and coming shallow is how you get found. So she doesn't. She sails with an understanding of what she is meant to accomplish, vanishes for 3 months, and the captain makes every decision that follows. There's a term for it. Mission command. You're handed the intent, not the instructions. The Germans got there first, and gave it a word with far too many consonants in it. In space, that isn't a leadership philosophy. It is the only thing that physically works. Reason 2. Detection gives you a direction, not a location. In fiction, sensors hand you a dot on a map. Range, heading, speed, ship class, instantly, with a pleasant chime. Passive sonar does not do that. Passive sonar listens, and listening tells you which direction a sound came from. A bearing. That's it. Here's the intuition. You're standing in thick fog and you hear a dog barking. You know exactly which way it is. You have no idea whether it's a small dog nearby or a very large dog far away. Those two sound identical. That's a submarine's entire life. So how do you get range? You move. You take a second bearing from a new position and compare. Do that enough times, and the geometry finally closes. It's called target motion analysis, and it takes hours. Space is the same puzzle in a different medium. An infrared telescope sees a warm thing against a very cold background. That's a direction. Turning it into a position and a velocity takes either a long baseline of patient observation or two sensors far enough apart to triangulate. Which means the space battle does not begin when somebody shouts, "Contact!" It began hours earlier, in silence, with one crew slowly assembling a picture of another crew, who are doing exactly the same thing back at them. Reason 3. The shot takes forever. A modern heavyweight torpedo runs for minutes before it arrives. Minutes is an eternity. The target hears it coming, turns, accelerates, throws out decoys. So you don't fire at where the enemy is, you fire at where the arithmetic says the enemy is going to be, and then you sit there and find out whether you were right. Now scale it up. In space, at realistic ranges, a kinetic round is in flight for minutes, sometimes hours, which produces the strangest fact about space warfare. Everything you're shooting at is a prediction, and everything you're looking at is a memory. The light showing you that ship left it minutes ago. It isn't there anymore. You are aiming at a ghost, with a gun that fires into the future. That is not a fighter pilot's problem. A fighter pilot's problem is measured in seconds. That is a submariner's problem, and they've been solving it since 1914. Reason 4, and this is the one that gets people. An Ohio-class submarine runs on a nuclear reactor. It makes its own power, its own fresh water, its own oxygen. On fuel alone, it could stay under for years. It stays under for 70 to 90 days. Why? Food and people. The USS Pennsylvania once managed 140 days submerged. A British Vanguard boat recently came home after 205 days away. Those are records precisely because they were miserable. The reactor was fine the whole time. The reactor is always fine. The limit is how long a human being can live inside a steel tube with the same 40 faces and no sky. Think of it as a car with an infinite fuel tank and a driver with a completely normal bladder. The engine is never what ends the road trip. Science fiction has this backwards. It obsesses over reactors, engine ratings, warp cores. The real constraint is the pantry. And the Space Force has just walked into this same problem from the other side. Right now, a satellite launches with roughly enough fuel to stop itself drifting out of its own orbit. And that's it. One tank, 15-year career, no gas stations. Every maneuver is permanent. You spend, you never get it back. Their phrase for the fix is genuinely lovely. Maneuvering without regret. That's real doctrine language. They're funding on-orbit refueling demonstrations, and they've put $25.5 million behind a company called Astroscale to fly a tanker targeting early 2027. They are, in other words, currently inventing the underway replenishment ship, which the Navy did in about 1917. Reason 5. Nobody is coming. When a surface ship is hit, an entire doctrine exists around help showing up. Other ships close in. Helicopters lift the wounded off. You can run the hull aground on purpose. Worst case, you abandon into water a person can survive in, at least for a while. A submarine has none of that. Past a certain depth, a flooding compartment is a problem solved by that crew, with what's already aboard, in the next 90 seconds. Or it is not solved. It's the difference between your car breaking down on a highway and your car breaking down on the moon. Same failure, very different afternoon. Space is the moon version, permanently. No shore, no surface to swim toward, no friendly hull that can reach you inside a week. Your casualties are treated by your own medic. Your hull breach is sealed by your own people. That is a specific culture, and it has to be built on purpose. Submariners already have it. Now, the objection. It's a good one, so let's do it properly. Somebody is already typing it. There is no stealth in space. And that's essentially true. A warship radiates heat. You cannot hide heat against a background sitting near absolute zero. Shut the engines down and your life support still glows like a campfire in a dark field. The ocean hides submarines because water swallows sound and light, and because the ocean is genuinely noisy. Vacuum hides nothing and is perfectly quiet. So yes, stealth is the one thing that does not transfer. But go back and look at the list. Stealth was never on it. Autonomy, patience, sensor solutions built slowly out of geometry, shooting at predictions, endurance capped by human beings rather than machines, self-reliance with no rescue coming. Not one of those requires being invisible. They come from operating alone, in 3 dimensions, in a place that kills you the moment you get sloppy. Vacuum qualifies just as thoroughly as 300 meters of water. Then ask what a surface fleet officer actually brings to orbit. Formations, engagement at visual range, real-time signaling to the ship next door, air cover, rescue. Space deletes every single one of those. Which brings us to the 2nd of May, 1982. A cruiser called the General Belgrano was sailing south of the Falkland Islands. She was 44 years old, built in New Jersey, commissioned into the U.S. Navy as the Phoenix. She was sitting at Pearl Harbor on the 7th of December, 1941, and she came through it without a scratch. At 2:57 that afternoon, a British nuclear submarine called Conqueror fired 3 torpedoes at her. The torpedoes were an unguided design from 1927. Straight runners. No computer, no seeker, nothing. 2 of them hit. 323 men died. And then, the part that actually mattered. The entire Argentine Navy went back into port, and for the rest of the war, it never came out again. 1 submarine, 1 attack. An entire navy subtracted from a war without a second shot being fired. That was not a technology victory. Those torpedoes were older than most of the crew's parents. It was a doctrine victory. And it's a pattern. In the Second World War, American submarines were under 2% of the US Navy in the Pacific. They sank nearly 55% of Japan's merchant fleet and 30% of her warships. The smallest arm of that navy did the most decisive damage by being patient, by being autonomous, and by being impossible to defend against everywhere at once. So when the Space Force reaches for a word like dogfighting, understand what's happening. We are describing a slow, patient, 3-dimensional hunt using vocabulary borrowed from men in fighter jets, because that's the vocabulary we have lying around. And when you're reading a space battle, and the fleets slide into formation, and the admiral calls maneuvers in real time from the flagship bridge, that's a costume. Underneath it is a wooden ship, in 1805, in daylight, on water. The first people to fight a real war in space will not run it like Trafalgar. They'll run it like a patrol. Quiet, alone, for months, computing firing solutions on ghosts. Next time, I want the other half of this, because doctrine wins battles, and logistics wins wars, and no fictional space navy has any logistics whatsoever. If you'd like to know why every fleet in science fiction would starve to death long before it ever reached the enemy, subscribe.